Okay, everyone, welcome aboard. Welcome aboard. Welcome to the last meeting of the Space Association for the year 2022, and we've got a pretty interesting program tonight. A bit of time in between to have a chat and socialise for those people in the room. Feel free to charge up your wine glasses at home if you're watching from home. Tonight's program, we've got John Coleman is coming along to tell us about the AUSROC II program, which took place 30 years ago, when I was just a lad. And then we've got a presentation in our last series in the Apollo Footsteps to the Moon series, which we've tracked the development, final sort of testing and missions of leading up to Apollo 11's moon landing, and then we've continued the series on after that to culminate in Apollo 17, which is happening 50 years ago this month. So, without further ado, if John's ready, we're going to hand over to John Coleman. John, make up. So, just be careful of the cables down there, John.
Is that a 30-year-old T-shirt as well? Yep. Has it been washed since? Washed it this week because it really needed it.
Alright, there you go. Hang on.
Oh, no, I'll adjust it.
Right?
I can adjust it.
Oh, right.
There you go.
Right, can you hear me here?
Close up.
Yep, time. Right, we're running. Okay, good evening, folks. I'm going to talk about the AUSROC II launch, which happened 30 years ago. 30 years and a couple of months now, but so I'm going to start off with a brief discussion of the AUSROC I launch, which happened in 1989. Then the AUSROC II campaign, which involved construction, static firing the engines, and a launch up at Woomera. Now, you can see the data sheet here, which was sort of rather than a specification, as a description of what we were hoping for. Basically, it was started by a bunch of Space Association members at a Space Association meeting sometime back in the late 80s. It's all a bit fuzzy when it actually was. But Harvey Bromfield put a notice in the Space Association news saying that he wanted to build a rocket. He got a few bites from a couple of people. Most significantly, Mark Blair, who was a 18-year-old student at Monash University at the time, and so they got together. They bought some designs for a rocket from a Air and Space magazine in the US, and started working on it. And basically, hang on, you've seen that. Spacebar. It was built in his home, in his garage, in my garage, all bits and pieces all over the place. And in fact, I've still got some of the bits in my garage, which he... But anyway, so in terms of infrastructure, you can see it here. It's a great big field with a gravel road intersection so that the rocket wouldn't set fire to the ground. Construction equipment, anything that could fit in the boot of a car. You can see here that there's a metal launch rail which was assembled again at his home. And it wasn't very big, it was like 3 or 4, well actually about 4 or 5 metres high. Hammered into the ground, just a big long rail that to keep the rocket running up in a straight line and until it was going fast enough for the fins to catch hold of the air. There you can see bits of the rocket. Again, it had to all fit in the boot of a car. So basically, when they got there, they've got a fin module you can see on the ground there, 4 fins, a tube which has got the actual motor in it, and then another tube that's got the parachute and the electronics and a radio transmitter. Bit more. Same thing. Okay, so there's the. This was all launched up at Greytown, which is part of the Puckapunyal tank range. It's a proof and experimental section of the army, and the guy you see here holding the front end of the rocket is actually a captain in the army, and the guy down on his knees doing all the work is the corporal, which is how these things work, and that's Mark Blair with the rocket there as part of the assembly process.
Is that gaffer tape?
Sorry?
Is that gaffer tape?
Most certainly is, yes. An awful lot of that stuff, yes.
Does that predate duct tape?
No, it's just pretty much the same thing. Yeah. All right, so basically the fuel and the oxidizer were hypergolic, which means you don't need to ignite it. You just, as soon as you pour them in together, they ignite. That is in fact extremely dangerous, because if you get even the slightest leak in one of the tanks into the other, and they were concentric tanks, so you get the slightest leak from one tank to the other, yeah, it takes off internally. So anyway, here it is, set up on the rail. Basically, the motor and the fins are assembled and put on the rail. The nose cone and payload are on the top of the rail, but taped off with gaffer tape that you'll see later. And it's fueled up on the ground, and then the payload is slid down the rail and then screwed on. Thusly, basically, that's all setting up the thing. The fueling had to be conducted by one person, which was Mark, in full PPE, with nitrous gloves and face masks and all sorts of things like that. So, and pressurised with nitrogen. And there he is when he's, and this is like about 1 kilometre away. This was a long lens looking at him. He's sort of on his own out there because, like I say, if it went wrong, it was going to go wrong really badly. There it is on the pad, ready to go. Oh, he's still there fueling up. Long shot. Whoops. That went by very fast. And there's the launch. The interesting thing about this is something we didn't expect. You can see the brown smoke coming out of the top end. Turned out that the tube, the launch tube, was hollow. So when they're motor fired, all the high pressure noxious gases and things at the bottom went straight up the tube and out the top. And but the rocket launched. It went up about 600 metres before the attachment at the front gave way and collapsed. The rocket kept going. Never seen again. Went out into the tank range, and when the payload broke off, the parachute deployed because there was nothing holding it in anyway. So it sort of floated off downwind in the opposite direction. So we sadly never saw that either. But there was a radio on it, so we captured the data from that. But yeah, lots of lessons learnt, which we used to go to the AUSROC II. That's just examining the launch rail afterwards. And that's the observation, looking back at the observation point where the people were standing looking at it. And that's where I was, which is about just over a kilometre away on a hill with the radio receiver and a Yagi antenna trying to, oh, which bit do I follow? Oh, that bit, yeah. So we got data, big learning experience, which leads us into now let's we just go down there. Is this going off or? Yep, that's it. Tough. Cool. All right, now the construction of AUSROC II. Again, it's considerably bigger. I mean, as soon as we finished AUSROC I, we were all pumped, and we said, "Oh yeah, we could do something bigger and better." So we did this. Basically, 5.5 metres long, 250 millimetre, a quarter of a metre, basically diameter. And it was going to be liquid oxygen, this thing. This was kerosene and liquid oxygen. So real rocket, which is another learning experience. 125 kilos dry weight, 90 pounds. So its launch weight is 200 kilos. And I think the thrust was about where are we? Yeah, about 100 kilos. Was that 1,000, was it? Yeah, all right. Anyway, lots of thrust.
200 would be enough to get it off the ground.
Good point. Yes. Now this is the layout, which is pretty typical for this sort of rocket, particularly your Redstones and those sort of rockets of the time. Kerosene at the bottom. Liquid oxygen at the top. No point pointing at that screen. Kerosene at the bottom, liquid oxygen at the top, a duct from the top right down through the carro tank to feed into both of them into the engine. On top of that, we have a big helium bottle, which is for pressurising the thing. So we need helium to force the stored pressure to force it in with no turbo pumps or anything. That's a little just another bridge too far, we thought. So then above that, the electronics module with the accelerometers. You can't actually read that. Oh, thank you. Yeah.
The people
Yeah.
online won't see what you're pointing at, so still describe it.
Yep. There's on the right-hand side of this thing. There's a at the very bottom. There's a hatch where you get you've got to fit all of the valves and electronics, sensors, and things like that in between the motor segment and the payload section, which is basically almost the same length. So helium bottle for pressurization, electronics module above that, plenty of room for a big parachute and a nose cone, and right on the very tip of the nose cone is a static tube which basically measures the Mach number. Liquid oxygen motor. The what you see in this diagram is basically all the little circles that you see. They're actually sections of a spiral. So it's what's called a regenerative motor, and that is to stop the inside of the motor burning away because it's so hot. You pump the kerosene, gets pumped in at the top. It goes right down to the bottom of the nozzle, and then pumped in a spiral all the way up, and that kerosene cools the inner shell of the motor and stops it from burning, because obviously liquid oxygen flowing in there with that sort of temperature is going to burn a bit of aluminium, or this is steel, but it's just going to burn it really quickly. And an injector. The motor and the injector were the hard parts of the manufacture, because the injector, as you can see, it's got 2 mm holes for the LOX and 0.5 mm holes for the kerosene. And there's, I think if it tells me here, does it tell us how many there are? No, but there's rings, and there's a lot of stuff, and there's a lot of sitting there with a drill, a tiny fine drill, trying to drill holes in this aluminium turning. And on the bottom right-hand side there is the cap on the top. This is the injector module, and basically the LOX comes in from the top, and the kerosene is fed into the side so that it could go down and through the spiral for cooling. Here's the motor, manufactured as in, so it's it wouldn't have the injector sitting on top. You can see the injector sitting on top of it there. This was just set up for display. It's made in parts, so you do the inner core, you weld on the spiral. Difficult to weld inside once you put the outside on, so basically this spiral is going to be a bit leaky, but it doesn't matter because it's just all kerosene flowing up anyway. So the kerosene comes in the bottom, flows up this spiral with these two sides welded on at the thing, and then another tube at the top to make the outer casing. This is the injector. Not quite the same as the original drawing, but it's got doublets, as in it's still quite complicated inside the injector because you've got to spread the oxygen and the kerosene around this big circle, and they have to then have holes aren't drilled straight down, they're drilled at an angle so that the streams that are coming out meet about 3 or 4 millimetres away from the surface and get blasted into each other, which atomizes them and mixes them to so that they'll actually burn. Between the tanks there's what's called inter-tank fairings, and again everything had to be made in separate little modules that all had to be welded together late. And here we got an inter-tank fairing and a fairing from the from the top. The upper valve fairing. This is a strange view. It's looking inside the lower valve fairing, and the strange star-shaped things you see around there are just scooped out aluminium just to make the weight lower, because it's all turned with a solid and then mass cut out to drop it. And you can see the inside of all of the hatch covers. They've got captive nuts on there sticking out, so that the hatch comes off. There's a captive nut, so you don't have to put nuts or threaded screws which wear out. This is the end of a tank, basically with the hole going through it. So that's the kerosene tank, another inter-tank fairing, and the kerosene tank at the bottom, where the oxygen comes through the centre, and the wiring from the top all down to the bottom all comes through a little another tube that goes through the centre of the tank. Another view of the same thing. This is a hatch, not very big. It's only a sort of a 1/4 metre diameter rocket, and so all the bits have to fit in there. Yeah, about that big. Yeah. And then the hatch goes in and is screwed on at the last minute. So basically, the hatch is sized big enough to stick a fist in it, and only one fist. So yeah. And this was a very tricky thing too, which is the pitot tube. Now, to measure your speed at supersonic speeds, you need a static pressure and a dynamic pressure. So half, or about a third of the way from the tip to about here, you can see there's holes in the thing, and that measures the static pressure. And the dynamic pressure is because the tube is hollow and pointing straight into the airflow. And part of the electronic package is 2 pressure sensors. You measure the 2 pressures, you do a bit of a calculation, and you come out with an airspeed. These are the main culprits. I don't know. Nothing like me. Andrew Cheers, that's me. That's Mark Blair. That's Norbert Leidinger, and that's Harvey Bromfield. So Harvey and Mark were sort of the initiators of this whole scheme. And Norbert was in fact a technician, managed the shop at BHP Research Labs. One of Mark's major skills is rounding up people, and so he got a sponsorship from BHP for $25,000 in terms of, so they could use the machining. So we had NC mills for machining stuff and the use of their technician. So I think we did that. That's a collection of all the valves and actuators and things that were needed to be screwed in, including the big steel flexible pipe which runs the oxygen from the top through the kerosene. This looks just like the AUSROC I launch rail, only much bigger. And again, that's being assembled in the wind tunnel at Monash University, because Mark wangled a third-year project for his engineering degree to be this project. So he got to use all the facilities at the Monash Engineering as well. So apart from technical excellence, you need to be an entrepreneur to get these sorts of things done. So that's it. See the wind tunnel in the background if you're wondering what that.
Is that still there, John?
I don't know. 30 years later. No, we actually had to hire a truck to take that up. Oh, sorry, borrow a truck to take that up. Yeah. Okay. Yeah, you'll have to do that, Ashley, because. You just click on the first one. Oh. Full screen. That's it. Now this motor needed testing. I've run over my 20 minutes already, I'm sorry, but yeah. Mark's talent of recruiting people, he recruited some people from the explosive factory at Maribyrnong. They had a rocket testing stand, which you see on the left of this drawing over here, and for testing big motors, and this one here in the right in the centre, it was on the little motors, and that's basically a hut on a set of rails which run out of there to cover what you're working on. But we just pushed the hut back, set up the oxygen tank on the outside, the kerosene tank on the inside, and the motor in the front, and the motor was butted up against a load cell which was measuring the thrust. So I'll zoom through here. Here's our dirty great big, what I think about 200 litre dewar of liquid oxygen, donated kindly by CIG. There it is. That's white because it's wrapped in foam. This is internal. This is a picture of the kerosene tank in the back here, with duct tape, yes. And a dirty big slab of steel between the motor and the kero tank, just in case. Another view from the front. Here we are starting to filling up the LOX tank. Cameras everywhere. Camera thinks it's hiding behind a wall there, but I don't think that's how it works. Just a detail here, the actuators is the yellow thing sitting on top of the motor there. The plumbing is not what you'd not physically what you'd have in the rocket, but it's obviously all of the pipe work is made much longer so that we could spread it all out and put lots more sensors on it than would actually be flying. This was to check the stuff of the motor. And there's a couple of the valves and a sensor. Lots of stuff. These are a couple of guys from the Maribyrnong Explosives Factory come along to join in. Lots of people wanted to help us out and join in and do these tests. This is the igniter system. The little guy in the on the footpath there is from EFM. And he built this, and he made the pyrotechnic composition that goes into this tube. And at about head height, that tube, you can see that there's lots of little holes around it. So when you fire that, it's fired sparks and flame out at right angles to that. Really nice facility that we borrowed. Lots of really high-tech equipment, none of which we used except for our little computer here and the power supply. All the rest is just decoration. CCTV behind a dirty, great big concrete slab, big concrete wall that you saw in the other picture. And there it is firing. This is our first static firing, fired nice. Still firing. This is a picture from the suicide cam, which is right up close. This is our second try. Didn't burn quite so nicely. Then it sort of went out. And then all of the oxygen started spewing out with no sign of any kerosene. And that's why. A weld gave way. So it had been it had been welded down there at the bottom, and for some reason it's split in the middle. You can in fact see the tube down the middle, so it's useful. And whoops. And that's it while it was still where it was, so everything was covered. That's just saying, it's hard to see, but that shows everything covered in kerosene. So, which first, sorry?
No smoking.
No smoking at all, yes, or it would start burning. And that's it. Yeah, just blacken at the end a bit, and yeah, still intact internally. Taking a picture of that and that. There's our little igniter thing, and its maker examining the results. And another learning experience, concrete. Yes, it gets hot. If it's just rained and there's water sort of soaks in a few millimetres, and the hot flame vaporises that water and the concrete explodes. So little shards of concrete get spewed everywhere, and yeah, big chips of concrete and flame everywhere. And that was the end of that. The static firing, actually.
That's folder 3.
Hmm?
That's folder 3.
Yes. No, that was 3. Sorry, I just don't know to operate things without a mouse. Just that one, yeah. I won't have time to do them. Okay. So that was, we'll just look at the data here. First statics was on the 15th of September 91. 15th of March 92 we got back with a new tank and ready to go again. Fired nicely. Oops. We did 2 static firings on this second day. And fired a second time on the same day, which proved that it could all work. Interesting point here is if you look up towards the gate, the little igniter got shot out. Fortunately, it just missed the gate. Otherwise, it'd have been out in that paddock. And, another lesson learned. Put a chain on it. We did next time. And in the second static firing, the oxygen tank was put at an angle of 70 degrees just so that it matched the actual launch conditions. Wow, this is really small.
What do you need? Next folder?
No, actually, I was just trying to get that second one there. I'll just do that in about, that takes about 2 seconds to run through them all. Right, this is just a side view of the static firing, just to show how the flame is reasonably consistent, and so this is just again remote control. Yep.
You're going to use it that way? Yep. Sorry, we'll just
Well-
go dot dot.
Oh, right, okay. Ooh, running horribly late here. And so, the anniversary we're celebrating is the 22nd of October. This is our oxygen tanks rolling up. Fortunately, the generosity of our sponsors included a dirty great big truck to carry it up there. There's all the internals of the rocket all spread out on the thing, ready to be assembled. The yellow trolley here is something that we found in the it was in the test shop when we got there. We thought, gee, that's nice. We can borrow that, can we? Yeah. Well, it is. Yeah, it was for carrying rockets around the range. Yeah, loading them onto aircraft and stuff. So, so basically, I just zoomed through that. Here's a whole bunch of the same sort of people assembling it all. It's been painted, and this is an internal shot of how all of that hydraulic gear and stuff gets actually crammed into a really tight space. And another one there. There's our parachute that slides into a canister in the top. That's the electronics package. Nice facilities with a nice little electronic workshop they had up there. Now here's Zupe with the camera. If you see that, there's a camera that was sticking out the side, looking down, and that's the electronics package, all assembled, sitting on the table there. Nice 80s technology there, all the electronics. All built and designed on my brand new 486 PC. That's the accelerometer array and the driver for it. And sadly, all of that is a single chip these days, a triaxial accelerometer. So, yeah. And the green package there are postage stamps because some guy wanted to do first day covers. There's the camera sticking out the side, and the antenna was in fact also sticking out the side and pointing bent forward. That's the launch controller box. The launch controller box is the box on the top with the keys in it. And a power supply for it underneath. The instrumentation building at Woomera there is got lots and lots of equipment, and all we bought was a sort of a row of PCs there on that one desk. All the rest in the background is just thing. There's the launch rail ready for us. In the background you see there's the JAXA launcher, the big one in the middle, and then various other launches. Test launching, test direction there. And basically once the launch wheel is down, you slide the rocket on with lots of people carrying it. It hasn't got the electronics module and stuff on the top there. That all has to go in later. Here's the electronics module going in. So it's slid down into its position. Parachute is slipped down on top of it, then the nose cone all wired up. Wiring up the bottom. Lesson learned here. Don't use Teflon for your pressure tubes because it burns. All ready to go. And then everybody on the balcony for the instrumentation building. We had a Channel 7 news crew. That's the guy on the right, the two guys on the right actually, and looking for the launch. Cameras getting out. Then every man and his dog is out on the balcony, ready for the launch. We're inside looking at the screens. Very difficult to see the launch, unfortunately, after all that effort, because we're all looking at screens. And, 3, 2, 1, fire, and you see the little yellow, little orange dot in the background. Not what we were expecting. Changed from portrait mode to landscape mode because nobody's expecting it to go up anymore. Yeah. And so what happened here is that the one of those little orange valves, yellow valves as you saw, didn't open all the way, and it was the oxygen valve. So there wasn't enough oxygen to generate enough lift to lift it off, but there's enough oxygen to start a fire. So there are little bursts of oxygen coming through. It was basically just dribbling through. But the kerosene valve opened nicely, and so it was just sat there pouring kerosene onto the ground with a bit of oxygen to keep it going, and it just sat there and burned. And now what we had to deploy the parachute was a timer. So basically when it launches, it breaks a wire and it starts a timer. Well, the wires break and also wires burn. So it basically started the timer, which is 42 seconds. Nobody knew that. So all those people you saw on the balcony, they saw all this going through, they saw this white mist going out, so all the flame died down. They all walked back in there, and then the timer went off, and it fired some explosive bolts which held the nose cone on. So there was a big bang, and the nose cone dropped off with the parachute. And everybody heard this explosion and all tried to get back out the door onto the balcony at once, and it was like the funniest thing I've seen in my life. About 30 or 40 people all going for the door. But anyway, so the parachute goes out. The whole thing keeps burning because, like I said, there's a duct up through the kerosene tank. The flame actually burnt up through that towards, and there was a video camera on the top. So we have a video which is looking back down, looking at a little fire down the bottom, and basically it's burning up this thing up towards the top. The kerosene runs out, but the kerosene runs out. The oxygen is sitting there, all of the gas to pressurise them out is all gone, except for the LOX, which is sitting there boiling. So the LOX goes back up the pipe, but the pressurising was coming down up into the pressure chamber, and back down the only other open tube was, which is the tube down to the kerosene tank. So we've got this empty kerosene tank full of kerosene fumes, and LOX comes down into it. And when the LOX gets down to the exit where the fire is, blam. The whole thing just blew in half. The LOX tank ruptured. And by this stage, everybody's out there watching. So the whole thing is blown in half at the centre. So the LOX tank, which is still pressurised because it's boiling, because there's a fire under it, the LOX tank actually takes off. Goes about 10, 15 metres, spins around, falls down, and the kerosene tank's blown off. So yeah, TV cameras all there watching it all. So editing that night on all of the TV channels, every TV channel nationwide, is all of the pauses in the middle cut out. So it's just catches fire, explosive bolts, nose cone drops off, blam, all in sort of 10 seconds, and it looked really pathetic. Really, really sad.
Is it on YouTube somewhere?
No, this would be way back in the early 90s. There wouldn't be any YouTube or anything like that. We've got videotapes, like I say, but I haven't been able to convert any of my videotapes. Another lesson learned, don't use permanent marker to write on videotapes because it fades away. And so I've got boxes full of videotapes, and what the hell is this? So here we got our the back end of the rocket was just blown off the thing. That's the rear end, that's the front end, and that's it. So, but 3 years later, thanks Ashley.
Oh, you show that on the camera.
Oh, yes.
It gives the details of it, how high, isn't it?
26th of May 1995. So you'll notice that there is a truss on the back of the launch rail this time, when it was just a rod before, because that needed stiffening up. And but the rocket takes off.
Fantastic.
And sorry, I went a lot over time.
Thanks, John. That was really good. Well done. And congratulations on the tenacity to get up and do it again and have a successful flight. How high did the second flight get? What altitude?
Well, it wasn't perfect, but it's, I think it's a couple of kilometres.
Couple of kilometres. Okay, terrific. Brilliant. All right. Well, just a final session for tonight. Our Footsteps to the Moon series, but I just did want to just touch base with a couple of things that have happened this morning. Actually, well, this happened a couple of weeks ago. This is the launch of Artemis, and as we probably all know, it went into a sort of a retrograde orbit around the moon and came back this morning. And there's a couple of shots here from a camera on board the spacecraft. The upper hatch of it has a window in it, and they had a camera pointing upwards, so you can see the deployment of the parachutes. And it landed about 4:40 a.m. Melbourne time off of the California coast. So seemingly went quite well. And as we were talking before, Back to the Future really, it's a capsule on 3 parachutes with red and white stripes, and 50 years after Apollo 17. But anyway, congratulations to NASA on that. A lot of people were doubting it was ever going to happen, so well done. Yeah, so this is my 50th anniversary Apollo series, the final episode of this. We started off quite a while ago, back in 2018, which was the 50th anniversary of the Apollo 8 mission, where they orbited the moon. They didn't do a flyby, orbited the moon, and we followed each step along the way. So yeah, it's basically, I realised back in 2017, 2018 how much development, testing and trials and errors took place between when we started this series, which was back around Apollo 8 time, to when they landed on the moon in July, just 8-9 months later. So I thought it would be quite interesting for us space geeks to take a good look at all that. So we started off in September 2018, and then we culminated in July 2019 for the 50th. And so my math is going off. And we kept it going just because of the fact that it was a limited run program, and it culminated in 2017, in Apollo 17. So this once again is the final episode. The whole series in a couple of days will be up on our YouTube channel. All these episodes are up there currently right now, so if you've got quite a bit of time to kill, you might be interested to go and have a look at that. So what we do in this, we just have a quick look at what was happening back 50 years ago. So December 5, the screening of passengers on carry-on luggage would be required at all American airports in 73. There'd been 29 hijackings in the US, and in 72 and 73 there were just 2. So obviously had a good effect. December 7, last draft call for the induction of American adults to the US Armed Forces. December 13, North Vietnamese, because the Vietnam War was ongoing at this stage, walked out of the Paris peace talks. Nixon issued an ultimatum to return to talks within 72 hours. 2018 begins Operation Linebacker 2, the most massive aerial bombardment ever made on North Vietnam. So pretty full on. Actually, interesting, the picture in the middle there, that was the picture of the conference that was in Paris that the Vietnamese walked out of, and below that is a picture out of Dr. Strangelove, and I thought the beautiful parallel between those two images was worth adding in. You can't fight in here. This is a war room. December 18, Neely Hunter Biden, the wife of US Senator Joe Biden, was killed in a traffic accident. December 20, Northrop Grumman M2F3 wingless lifting body made its final flight, achieving an altitude of 71,500 feet. December 25, unpublished decree took effect in USSR, making it illegal for Soviet citizens to meet with foreigners for the purpose of disseminating false or slanderous information about the Soviet Union. Yuri Andropov, the director of the KGB, recommended that Soviet Politburo allocate $100,000 to influence the March parliamentary elections in Chile, and that was approved in February. 1972, December, Soviet Union governing presidium approved an order changing the Chinese-sounding names of 9 cities in Siberia that had been seized by the Russian Empire from China in the 1860s. Sounds a bit familiar to things that are happening at the moment. December 27, US Environmental Protection Agency issued a new regulations requiring unleaded gasoline. December 29, Edward Lorenz proposed the now famous butterfly effect in a paper delivered to the American Association for the Advancement of Science. Predictably, does the flap of a butterfly's wings in Brazil set off a tornado in Texas? I don't know what the answer to that is. In Australia in 72, the ALP led by Gough Whitlam won 67 of the 125 seats and kicked out the Liberal Party. He'd been in power for 23 years. He was sworn in 3 days later and introduced dramatic economic, social and political reforms. Withdrawal of troops from Vietnam, freeing imprisoned draft protesters and setting up ties with China, North Vietnam and East Germany. Shane Gould was announced as the Australian of the Year. And health warnings, smoking is a health hazard, becomes compulsory on cigarette packets in Australia. Also, December in 72, the last Australian servicemen to serve in Vietnam War were brought home. ABC's children's television program, Adventure Island, broadcast its 1175th episode. Adventures of Barry Mackenzie, starring Barry Crocker, telling the story of an Australian yobbo, was released. And this, I like, this is a an advertisement in Target Catalogue Australia of 1972. Actually, John, a lot of these people look a bit like the people over at your rocket launch in South Australia. So, top 10 back then, December 72. Popcorn by Hot Butter. Burning Love by Elvis Presley. Etc., etc., etc. No Beatles there. Can't believe that. Also, Cat Stevens, that album, Catch Bullet 4, I'd bought that back then. Love that album. So, Apollo 17 started December 7 and ended up in December 19. So, they were 11th crewed Apollo mission, the final mission of humans to set foot on the moon. Selected the Taurus Littrow landing site. And as you can see, the crew, I'll go back. There was the crew there, Harrison Smith, lunar module pilot, Ron Evans and Gene Cernan. So just a quick whiz through some of the timeline. Back in 1970, October 27, the second stage for the 17 vehicle was offloaded at the vehicle assembly building, return base in there. 69 announced the backup crew for Apollo 14 would be Gene Cernan, Ron Evans and former X-15 pilot Joe Engle. So that put them in line. The way NASA worked it, they would select a crew, a backup crew, and then you'd be normally entitled to fly the third mission afterwards. Harrison Smith was a professional geologist who'd been serving as a backup crew in 15 and would fly the lunar module pilot on Apollo 18 as a result of the rotation. In September 70, Apollo 18 was cancelled and the scientific community pressed NASA to fly a scientist, a geologist, rather than a pilot. So they assigned Jack Schmitt to Apollo 17, and of course they bumped Joe Engle out of the assignment. So Joe Engle took that very graciously. Ultimately chose Cernan and Evans through support assigning Cernan to Apollo 17, but it was not unanimous in NASA, which is interesting. I read this up in researching a while ago about the death of Jim McDivitt. So in January 23 of 71, Cernan crashed his Bell 47G helicopter in the Indian River. It was later attributed to the pilot error as he'd misjudged the altitude before crashing in the water.
Young ladies on the.
Yeah, I get to that. So Jim McDivitt was the manager of Apollo space program at that time, and he objected to Cernan's selection, citing the incident, though Dick Slayton dismissed the concern. After offering the command of the mission, Cernan argued that Engel should fly with him on the mission, but agreed to Schmidt's selection when it came clear that Schmidt would fly on Apollo 17 with or without Cernan. The prime coup was then publicly announced. So that picture on the bottom right is Cernan's helmet that he was wearing in the helicopter at the time. On October 71, the NASA press release stated that misjudgment in estimating the altitude was the primary cause of the crash. So regarding this helicopter accident, later accounts, one of which was written by Cernan himself in an autobiography, it was revealed that Cernan was flying too low and showing off to nearby boaters. Sounds like Cernan. All right, so August of 13 of 71, they formally announced the crew. Cernan was selected back in 63. He flew on Gemini 9 and Apollo 10, and he was backup commander 14. Evans, selected as an astronaut in 66, would be making his first flight, and Schmidt was selected in the first group of scientist astronauts in 65. I believe he was selected around the same time, or in probably the same class as Australian-born Philip Chapman. He'd be making his first flight on Apollo 17. So March 72, they were just undergoing final fit checks for their suits, and particularly like that picture in the left bottom hand corner with the unique 70s fashion statements there, mustaches and big long sideburns. This is an interesting picture. This is Gene Cernan practicing in EVA wearing Dave Scott's actual lunar suit. The reason was that he used Dave's suit at that point in time. His training suit wasn't yet ready. Both Scott and Cernan were similar size, and hence Cernan was able to use that suit for training. Apollo 17 and the CSM, the lunar module and the CSM, were docking tests in May the 2nd of 72. May 15, the first stage was erected in preparations for the mission. Overhead crane raises Apollo 17 first stage for erection onto the mobile launcher, and then they mated on June 23, the third stage, after the second stage obviously was mated, to form the final stack. June 5, the lunar roving vehicle was unpacked at KSC, and I'd put that picture again. I don't know why I did that. Anyway, yes, so there's the third stage being stacked on the top. August 1, the CM was moved to the VAB for stacking. Note, Ron Evans is driving behind the wheel of the transport truck. Ron Evans was all over the vehicle through the entire ground preparation, building, construction and testing. Really smart guy apparently, and a very hands-on sort of guy. So he's there once again. He's talking with the McDonnell Douglas personnel inside the interstage during the second and third stages. August 4, Gene Cernan posing with his family and a daughter's friend. Love once again the 70s fashions and colour. August 9 of 72, during the final LRV fit check. So they basically plugged everything in, life support systems into the suits, plugged the suits in, plugged all the communication, checked all of that out, made sure everything fit, everything worked, everything communicated, etc. before the final stack. So now we have August 16, the lunar module undergoes testing prior to being closed in the adapter, because you couldn't have a lunar module sitting out there in the wind because it's not strong enough, so there's an adapter that goes right over the top of it. So the spacecraft passes with the S-1B booster intended for the first manned Skylab mission. busy place around their VAB. So the Apollo 17 spacecraft is gently lowered down on top of the instrument unit on the rest of the Saturn V vehicle. Training continuing. Backup commander John Young, who is the backup commander to the prime crew, sitting in the lunar rover training vehicle, and they're doing EVA training out there, scoops of soil, etc., into the sample bags, etc. A lot of hours of training. Here they are, because as the Apollo moonwalks or EVAs progressed, the problem of dust was significant and fouling up equipment and etc., etc. So they were more and more concentrating on trying to keep the lunar module clean as much as possible. So they would try to brush each other down on the surface just before they went into the vehicle. Even then, it was really, really difficult. So rollout time was August 28, and they watched their vehicle out to the launch pad, launch complex. Be pretty cool standing there watching your rocket roll out. And then there was the famous pictures that we've all probably seen, the crew suited up in front of the stack on the pad. More training, lunar roving vehicle training at KSC. Self-explanatory. Here's Ron practicing film handling cassette to Harrison Smith seated in the spacecraft mock-up, because what they did is they had a whole bunch of cameras on the service module, filming, taking pictures of the surface. On the way back to the Earth, Ron Evans, the command module pilot, did a deep space EVA to go and retrieve those camera films. That was the third and final deep space EVA. So here's Ron doing training in a water tank with his suit and everything. In fact, he used Gene Cernan's lever. It's an over helmet to their clear bubble helmet, which actually Gene Cernan used on the moon, as well as the mini backpack at the top, the emergency backpack. So that's what Ron used in the deep space EVA. Some more training. October 17, Gene Cernan preparing to train in the lunar training vehicle at Ellington Air Force Base, and then October 20, egress training in a tank. Unlike previous crews where they'd done it out in the Gulf of Mexico, they just conducted this splashdown recovery training in a water tank at Manned Space Flight Center. And here's a funny picture which no one really seems to know the origin of, but I think you see films that back at that time that at least Charlie Duke and John Young, who were the moonwalkers on Apollo 16, had grown moustaches, and I think the prime crew decided they would fit some moustaches and make a bit of fun. Actually, it's pretty funky. The Apollo 16 command module pilot growing the full blood nut beard or goatee, etc. Stu Russo. Alright, so continuing training, October 27, doing some Ron Evans in the middle there with the green shirt, doing some lunar surface training, identifying areas that they wanted to focus on for photography, etc. And Gene and Jack in the lunar module training simulator. In fact, if you want to go to, I think it's at the Kennedy Space Center, it might be Johnson Space Center, that actual training lunar module cabin is there to have a look at. I think it might be at Huntsville, actually, is it? Yeah, anyway. Okay, my thing's not responding. Get the expert in. It's just not responding.
Zap.
You're static for electricity, man. Yeah.
Yep.
I've been using the keyboard. Is it still working?
Yep.
There we go. Is this audio stuff?
Yeah, I've just got to fix something.
a bit of audio tune-up here, ladies and gentlemen. All right, so then November the 2nd, the senior management met at KC for the flight readiness review, which they approved the December 6th launch date, which will be the first night launch, which is quite a coincidence because the Artemis launch that happened a couple of weeks ago was a night launch as well. And as Gene Cernan said, we didn't do it for romantic reasons or cinematic reasons. It was all about orbital mechanics where the moon would be in relation to the Earth and for the lighting conditions of landing, which is the most critical part. Some more training out in the field. You can see a little mock-up lunar module there, climbing up and down. And I love Gene Cernan's 72 fashion with his checkered pants and beanie, etc., etc. And here's the green beanie flying around, driving around in the Grover, they called it. It's the training version of the lunar rover vehicle. November 10, they held a press conference and released a design of their patch, elaborating on the themes, etc., of the Greek god of Apollo, etc., etc. They released the names of their vehicles, America for the command module and Challenger for the lunar module. Gene Cernan congratulates the lunar landing training vehicle ground team following his 46th flight aboard the training vehicle, and that was the final flight of that vehicle. Very difficult to fly, very touchy, tricky, but all of the astronauts say that there was invaluable training. So if you ever get access inside the Teague Auditorium at NASA, you need to have a press pass or some other special tour. It's actually hanging up in the ceiling there. I've seen it a couple of times. It's quite amazing. It's quite an amazing vehicle. All right, so November 15, the ground controllers and launch team conduct the countdown demonstration test. This is where they run through all the processes of fueling up and testing the systems, etc., etc., to make sure that all of their systems are correct. And then the astronauts themselves, on November 21st, they went out for their participate in the last day of the countdown demonstration test, suiting up with the actual flight suits, all the exact steps that they would take on launch day to make sure everything was going to work correctly. So then they went out to the launch pad, into the White Room. Some of the experiments that they were running, I'm not going to go through all of them here, but Gene Cernan trains with a drill to place probes for the heat flow experiment. And that heat flow experiment, basically they drill a hole and they would put a probe down and measure the temperatures down there. Remarkably, I think it's about a metre below the surface. It's actually, the temperature is quite consistent regardless of night and day, which is a 2-week cycle on the Moon, of course. All right, November 2, I think I've just done this slide, haven't I? I don't know if I did that. Okay, December 4, the crew went out on the swing arm, number 9, to the pad, and below that, on the left-hand side, they're out visiting the rocket for the last time before they take them off to the Moon. Man, it must have been amazing to be standing at the base of that thing. Well, it's going to light up soon, and I'm going to be on it. You see that light there on the swing arm? The one that I've just swung in there is actually mine. This is, I rescued it from NASA back about 10 years ago. What happened is they were going to trash all of the mobile launches other than the parts that they use for the shuttle fixed service structure. But there was a big campaign to try and save at least one of them. So they said, look, I can't keep it erected. It's too much maintenance and danger of it having collapsed. So they cut it up and put it in sections in what they called the boneyard, where it sat for many years. And I was over there one time for a shuttle launch, and it was announced that the thing was going to be, it was seeping lead paint and toxins into the soil, and it was going to be taken away and destroyed, recycled. So me and a couple other guys, we wanted to go out to that boneyard. We've been there a few times before and taken pictures, but we went out and said, "Can we have a final look?" Yeah, no worries. And here I was walking along swing arm 9, which is the actual arm that the astronauts used to walk out to the actual capsule. and here's this light sitting there saying, "Take me home." So I had to talk to my guide, who I won't name, and he just passed away recently, actually, sadly. And I said, "Would you mind if I took that?" He goes, "I know nothing." That's the trunk of the car, put it in there. So I did that and a few other nuts and bolts and things like that. So I packaged it up and brought it home to Australia. So it sits in my house in, I'll probably get the FBI or CIA after me now. But anyway, there it is. Okay, so December 6th, of course, I launched in December 7, but this was December 6th, the night before midnight. They had their final traditional breakfast and sitting pressure checks on the suits. That picture in the middle, black and white one, Ron Evans gets a handshake from Deke Slayton. And Ron Evans says goodbye to his wife, kisses her through his helmet, which is quite lovely. Back up the top of the launch tower, the closeout team wishes Gene Cernan good luck and prepares them to get in the command module, and they prepare to get into that. And then the launch itself, once again a night launch, and quite spectacular from all accounts, and lit up the whole Florida coast with the light from that launch. So that was 4:33 p.m. On the 7th of December in Australia. I think this is a film. Yeah, here we go. Now I've got a little. It's a very. How does it go for? Little 22-minute documentary, just covers the highlights of it, because I'm not going to go through every step of the EVAs, etc. So hopefully this will come out. We have to go that way. Love the 70s film. Is this set up for audio?
December 6, 1972. Eugene Cernan, veteran astronaut and commander of Apollo 17. He would be the last Apollo astronaut to stand on the surface of the moon. Dr. Harrison Schmitt, better known as Jack. He would be the first geologist to set foot on an alien world. Ronald Evans, command module pilot. He would remain in lunar orbit, operating a battery of experiments that would take this last close look at the moon. In the year 1675, Sir Isaac Newton was asked by his fellow scientist, Robert Hooke, how he had accomplished so much. "If I have seen further," Newton wrote, "it is by standing on the shoulders of giants."
One command, pressurized S4B stage, was not given. And despite the fact that it was going to be done manually, the sequencer in effect said, "I didn't tell you to do it, therefore you can't be doing it." So at 30 seconds, it very properly stopped the operation. Most of the work was being done right off the firing room in the Launch Control Center at Kennedy. However, there was a great deal of support from the Marshall Space Flight Center, who had a comparable operational group working there with their contractors. So we concluded that we were safe, and we gave the word to jump route to one signal and proceed, which we did.
Houston, you are go for orbit. Go for orbit.
Those are kind words, Robert. We're go for orbit here.
After checking out the spacecraft in Earth orbit, they burned out of orbit and headed toward the moon.
Houston, we're right in the middle of a snowstorm. We're not there yet, long way.
Ron Evans, at the controls of the Command Module America, moved in to dock with the lunar module Challenger. They pulled Challenger free of the booster's third stage, then continued the 3-day coast to the moon.
GNS, ATM, ECO.
Even as Cernan, Evans, and Schmidt headed toward the moon, directly below the Apollo 17 control room, Flight Director Don Putty ran his crew through a launch simulation for the first Skylab.
As you're probably well aware, we are still working on other programs, Skylab being the prime effort starting in the spring of next year. We're also working on the cooperative mission with the Russians, which will take place in 1975. And of course, we've got quite a few of the flight control team as well as other center elements involved in the work on the shuttle. So it's the start of a new era, I hope.
Skylab, of course, will fly in the spring of next year with 3 men going up and spending 28 days, and then 2 months later after they land, we'll put 3 men up for 56 days. They'll come down, and 30 days later, another 3 will go for 56 days. So a year of 73, calendar year, will certainly be a busy one from the standpoint of manned spaceflight.
December 10th, 1972. America and Challenger went into orbit around the moon.
Houston, this is America. You can breathe easier. America has arrived on station for the Challenger head.
The next day, December 11th, Cernan and Schmidt entered the lunar module and undocked.
You look just as pretty in Earth light as you do in sunlight. Roger, America. Have a good burn. You're loud and clear.
With the command module in the distance, they passed over their landing place, a valley in an area of the moon called Taurus Littrow. Here they hoped to find the youngest material yet sampled and direct evidence of lunar volcanoes.
You're looking real good, Gene. Right down the line.
Oh, man, we're level with the top of the massif now. Okay, stand by for pitch over. Oh, are we coming in? Pitch over is proceeded. And there it is, Houston. There's Camelot. Wide on target. I see it. We got them all. 42 degrees, 37 degrees, to 5,500. 53 degrees. Okay, I've got Marhay, I've got Poppy, I've got the triangle. That's 2,500 feet, 52 degrees. H-dot is good at 2,000. H-dot is good. Fuel is good. Going down at 10, cut the H-dot. The fuel's good. 110 feet, stand by for some dust. Little forward, G. Bigger forward a little. 90 feet. Little forward velocity. 80 feet. Going down at 3. Getting a little dust. Going down about 2. Very little dust. Very little dust. Stand by for touchdown. Stand by. 25 feet. Down at 2. Fuel's good. 20 feet. Going down at 2. 10 feet. 10 feet. Contact. Stop push. Engine stop. Okay, Houston, the Challenger has landed.
Roger, Challenger, that's super.
Houston, you can tell America that Challenger is at Taurus Littrow.
December 11th. Cernan, then Schmidt, left the lunar module to begin their first EVA.
As I step off at the surface at Taurus Littrow, we'd like to dedicate the first steps of Apollo 17 to all those who made it possible.
Their first job was to unload equipment, including their rover, the electric car in which they would drive to the exploration sites.
That's beautiful. This has got to be one of the most proud moments of my life, I guarantee you. We thank you very much.
As Cernan drove the equipment-laden rover, Schmidt carried the scientific experiments package called ALSEP.
Hey, do you need me, Gene? Nope. I'm going to go deploy an ALSEP. Have at it.
In Houston, scientists in the science support room watched, correlating and directing their movements.
Okay, Bob, I've got my tools of the trade right here.
As Schmidt set up the various experiments, Cernan drilled a series of holes, both to collect core samples and to implant experimental probes.
We're out in the ejector blanket of Camelot for sure now.
Yeah.
Man, it didn't feel like this stuff was that hard. No, I'll get it. I knew there was something I needed to do. Get the jack in over here, other side. Let me put some weight here.
Not going anywhere.
Oh, he's going slowly, Bill. Very slowly.
I'm gonna get this thing out now that I got it. Boys, you know, that's what you call getting down into your work.
Yeah, it's 29 and a half minutes from now, but remember, they left this side a little bit late.
There he is. Okay.
Jim, you better make it clear to Parker that we got to pull out.
On the moon and on the Earth, they were fighting time now. There are just so many hours of oxygen and water in the backpacks. So many hours of life in the vacuum of the moon.
We're up in this area.
There you go. Watch that cable. Cable.
Oh!
Cable.
Watch the cable. Cable number 1. You know, they're all fixed, Lee. They'll break the whole world before they'll break the cable this time.
With the ALSEP functioning, they left the site for a shortened sampling traverse.
Well, many parts of the ALSEP are functioning very well. The heat flow experiment is working excellently. It's transmitting back temperature data. The cooling down is still cooling down from the drilling process, and in a few hours they should be starting to get true heat flow information.
Let's see if I can't crack the corner and get that contact. See if I can't get her.
Look at the boulders out there.
It was time to head back to the Challenger, activate experiments, and get back inside.
Man. I was strolling on the moon one day in a merry, merry month of December. No, May's the month. May, that's right. May is the year of the month.
As the astronauts rested, engineers in 2 nations were working out technical problems of the Apollo-Soyuz test program, the first joint Russian and American space mission.
Well, the prime purpose of the Apollo-Soyuz joint mission is to prove out a compatible docking system and demonstrate that we have compatible operational procedures that will let 2 different countries dock in space. I think more than that, it has certainly a symbolic meaning of these 2 large powers learning to work together in space, which I believe are the new seas of mankind, the new frontiers, and work out solutions to problems wherein, although we're very competitive, we can still be cooperative and assist each other. And I think that this Apollo-Soyuz program stands for just that.
Oh, what a nice day. Oh, funny, there's not a cloud in the sky, except in the earth. Like that'll stop the dust, that way?
They would have one task before they got to work exploring. The previous day, they had broken a rear fender of the rover. The dust thrown up was causing trouble. Apollo 16 commander John Young had worked that night in a pressure suit on a way to fix the fender.
Oh, okay.
On the moon, the astronauts put it together. The fender section formed from a lunar map, molded with tape, then held in place with clamps from the Lunar Module Telescope. It was a repair that would last the remainder of the mission. Then Schmidt moved out to place one of several explosive packages which would be detonated after they left the moon, mapping the lunar subsurface, much as earthly geologists explore for oil. Cernan would pick him up in the rover for the drive to the first site on this traverse, Station 2.
They're somewhere along this rim where they can see.
But they're dropping, Bill, so they must be coming across that thing.
We're right where we wanted to be for Station 2, and it looks like a great place. Big blocks. It looks like quite a bit of variety from here. Different colors, anyway. Pretty hard, isn't it? That boulder's going to roll. Man, that is hard. Just don't stub your toe.
The foreground features are somewhat different, simply because they were farther up onto the hill, I think. But otherwise, that's remarkable.
Pottery, it's obviously very cohesive because the bottom of the core is not smooth. It's very jaggedy and fragmental-like.
Gene's finished with the core tube, then we should be able to go.
If we get that
Get all of that?
Oh, dadgummit.
Jack Schmidt having a few problems.
They would sample several locations on this EVA, but none would cause more excitement than the find of the crater called Shorty.
Oh, hey! There is orange soil. Well, don't move it till I see it. It's all over. Orange. Don't move it till I see it. I've stirred it up with my feet. Hey, it is! I can see it from here. It's orange.
That's the volcanic mix.
Somebody unplugged silver.
Fantastic, sports fans. It's trench time. Jack, that is really orange.
I think it's the most exciting we've come across since the beginning of the Apollo program. I believe that it's going to be the most rewarding of all the finds on Apollo.
Light gray material on either side. Oh, man, that's incredible. Hey, Gene, we're going to have to... That's incredible. You need to get a down sun color.
There isn't enough time, Tony, to do it, no matter which way you want to do it. We need more time. We may have to flip. We have to flip 5 in a little bit, Bill.
He's getting about 3 centimeters of wax.
They got to leave at a certain time regardless of what we got.
Willing to give up all the light mantle stuff.
They had to leave Shorty Crater and its orange soil and push on. Time, the enemy of the lunar investigator on the moon and on Earth.
I can't believe we sampled the whole... I can't believe we sampled the whole thing right on.
The precious minutes had run out. Return to the rover, drive back to the Challenger, close out EVA-2.
We'd like you to leave immediately. Okay. My golly, this time goes fast.
As the last Apollo crew worked on the moon, the engineers on Earth prepared for tomorrow's day in space.
I have a model here of the space shuttle. As you see, it resembles a double-wing airplane on top of a propulsion system. The system is going to be designed so all of the costly parts are reusable. Now that we're beginning to understand
space. We're beginning to understand the potential, the economic potential. The need is to bring larger arrays of instrumentation up in space. There's a need to provide man with a real capability to work up in space.
Okay, Bob, I'm on the pad, and it's about 4:30 a Wednesday afternoon as I step out onto the plains of Torres Littoral. Beautiful valley.
December 13th. Yesterday, they had explored the south end of the valley. Today, they would go north.
Yeah, well, let's ask for an extension. Hey, Jim, this is the last time for you to really go to bat for us, Jim. We know you'll do it for us. 10-minute extension for that outset. Yeah.
Holy smoly! Why are we on a slope? You okay?
Man, that's rough country in there, isn't it?
Well, you're looking across Henry.
And let me see what it is.
Apollo science will continue, and I'm sure you might say the mysteries will continue to come out for many years to come.
But of this I'm sure. Man has learned that space is his to explore. And man will return to space to explore, to the moon and beyond.
I'm firmly convinced that it's changed the whole basis of philosophy, including religion. I don't think that we've begun to see what the era of spaceflight really is. We've got a long way to go, and I hope I'm living when we leave this solar system on a venture to find another planet Earth.
You know, Jack, when we finish with Station 8, we will have covered this whole valley from corner to corner. That was the idea.
Once more, it was time. Gene Cernan and Jack Schmitt returned to the rover to drive back to Challenger. But before they left the surface of the moon, there would be a brief ceremony.
It's a rock composed of many fragments of many sizes and many shapes. When we return this rock, or some of the others like it, to Houston, we'd like to share a piece of this rock with so many of the countries throughout the world. We hope that this will be a symbol of what our feelings are, what the feelings of the Apollo program are, and a symbol of mankind that we can live in peace and harmony in the future.
And a final word from the last man on the moon.
I'd like to just let what I believe history will record, that America's challenge of today has forged man's destiny of tomorrow.
While Cernan and Schmitt closed out the last moonwalk and prepared for tomorrow's liftoff, Ron Evans worked on in orbit. Photograph, observe, describe. Keep operating the cameras and experiments in the Science Experiments Bay. In orbit, as on the surface, the seconds are precious.
Possibility at this stage.
How is the experiment working now?
Working extremely well. We're looking for subsurface geologic structure in the broad sense, layering, for example.
This is the infrared scanning radiometer.
What does that do?
The radiometer measures the temperature of the moon and makes an accurate map of the temperature beneath the spacecraft. It is working with tremendous success.
One other thing, how is the experiment working mechanically as far as the man and the machine?
The experiment itself, the hardware is working perfectly, precisely the way it was supposed to work. Everything is functioning properly. An important part of the experiment is it requires the man to operate it.
99, proceeded, 3, 2, 1, ignition. Right away, Houston. Vets are good. Ag thought. Pitch over.
Roger, you have good thrust.
Okay, 30 seconds. 308 your number. Okay, coming through 1,500 feet, and H-dot looks good.
On the descent stage of Challenger, forever on the moon, they left a plaque reading, "Here man completed his first explorations of the moon, December 1972 AD. May the spirit of peace in which we came be reflected in the lives of all mankind." One revolution later, Cernan and Schmidt caught up with Evans and prepared for docking.
Good to see you. Good to have you all back up here. It's been a good trip. Man, that Challenger's a beautiful vehicle. You betcha.
December 16th. Burn out of lunar orbit and head home to Earth.
Houston, America has found some fair winds and following seas, and we're on our way home. Hey, this is great. Talk about being a spaceman. This is it.
December 17th. 170,000 miles from Earth. Ron Evans left the command module.
Hello, Mom.
We see you, Ron. Looking great.
Okay. Hey, John. How you doing? Hi, Jamie.
Evans was retrieving film canisters from the two cameras and the lunar sounding radar. Data vital to the scientists on Earth.
And the lesson's in.
Before he got back inside, Evans took a last look at the crescent Earth. In 2 more days, they would be home. December 19th. They rode inside a 5,000-degree fireball through the atmosphere of Earth. Stowed in the spacecraft, almost 250 pounds of the moon.
This closes a golden chapter in the age of space exploration. In a way, it brings a close to what has been a very romantic era in space exploration. But, I want to make this very strong, the book is still being written.
Okay, so that film is almost finished, so we'll just catch up to where we are tonight. And so just have a look at the Ron Evans was born in 1933 and he passed away in 1990, just aged 56 years of 56 years of age, very young. Gene Cernan, who came out to Australia 2016, was it, I think? And he passed away in 2017. He was 82. And Jack Schmidt is still kicking along. He's age 87 now. So well done, Jack. Interesting, when they got back, they were hosted by Richard Nixon at the White House in Camp David. Cernan and Evans refused to meet with Muhammad Ali, but accepted the hospitality from Frank Sinatra. So Muhammad Ali was a very controversial figure, particularly at that stage, because he'd refused to go to Vietnam based on his religious beliefs, etc. And at one stage, I think he was going to be sent to prison, but that didn't happen. Evans later was a backup for the Apollo Soyuz project, and the Russian he learned years before came in handy, but was limited. Asked to give a speech at a Cosmonauts dinner event, he recited Humpty Dumpty in Russian, which all the hosts found very humorous. Evans retired from the US Navy on April 30, 76. Remained active with the Astronaut Corps and involved in the space shuttle development. He served at the Operations and Training Group at the Astronaut Office and retired from NASA in 1977. If you want to go and see the command module, which is only part of the Apollo 17 vehicle that came back to Earth, it is on display at the Space Center at Houston. It's now called the Lyndon Johnson Space Center. Interesting, this year in April, you probably recall seeing on the film there, they were drilling and hammering core samples into the surface. So they actually they'd kept those in sort of cryogenic or vacuum sealed for all these years, and they opened the last one of those core samples, which were taken in '72, recently at the Johnson Space Center. So these are the core samples, etc. This particular one that opened was at this location at Station 3. So this is the landing site today, seen from the Lunar Reconnaissance Orbiter. And as I mentioned before, a number of us here in the room actually met up with Gene Cernan at the it was at Melbourne Town Hall, wasn't it? Oh no, it was Yastor. It was Yastor, yes. So a few of us put together some shekels and bought him a Kubra hat, which was warmly appreciated because he's from down south. However, it was a bit big for him, so trying to get his head dimension from Australia was a bit difficult, but he had a bit of a laugh about it. And I think, Len, you took him corrected size one. Fantastic. Yeah, that's lovely. Yeah. Yeah, he had gone to hospital. Yeah, he had gone to hospital, I think, a couple of times while he was here in Australia. Yeah. Now I don't know the actual era of this. It was back in the late '70s, early '80s, maybe.
The early '80s, because we ended up having lunch with him somewhere, I think, down the Nepean Highway.
I wasn't around at that stage with the group, but I met him at Doncaster's Shopping Town. That's me in a mock-up suit with him. He was a lovely guy. I had a quick chat to him, and
I thought it was the '70s too. Whenever that lunch was, because he did come to Australia, obviously, he did say to the group of us, he said, if you're ever in Phoenix, Arizona, well, that's waving a red rag to a bull, isn't it? So I was in Phoenix, Arizona, I made contact with him, I spent a day with Ron in Phoenix.
Fantastic.
What year was that? That was January '87.
Wow.
That was when I met him, it was January '87. But when do you reckon that I reckon early '80s. I reckon it was the '70s, but you could be right.
Yeah. So this is just a quick, very recent message that Harrison Smith sent to a group of tracking team in Australia, primarily from Honeysuckle Creek, but also other tracking stations. So it only goes about 3 minutes, this one, but it's like 2x old. If I can get the thing to work. Here we go.
December 8th, 1972. Ground elapsed time 21 hours, 41 minutes, 38 seconds.
Roger, Honeysuckle, I read you.
Honeysuckle, 17's reading you loud and clear.
Roger, we have a comm outage. I'll be right with you.
Okay, very fine. How are things down there today?
Fine, your weather report was beautiful.
Your country looks beautiful from here.
With that brief, fine exchange 50 years ago with Laurie Turner, Honeysuckle became a verbal part of the story of Apollo 17. Like hearing Neil Armstrong's first words from the moon through Honeysuckle in July 1969, it meant a lot to me on the last Apollo mission to talk to Honeysuckle in December 1972. In addition, my 3 days of weather reports for the South Pacific always emphasized Australia, so finally talking with you was frosting on the cake. It is great to send you greetings from Apollo 17 on the occasion of our 50th anniversary. Does it seem like 50 years? Not to me, but calendars don't lie. Much happened in the 14 years Honeysuckle served the free world between 1967 and 1981. The antenna you and your colleagues played an essential role as space warriors in the Cold War. The Doppler tracking data provided by Honeysuckle and its companion antennas made up a fundamental component of the overall navigation system for all Apollo missions. It was an essential part of the integration of crew star sightings, Doppler tracking, and computer computations. Even before hearing Neil Armstrong's words, there was the extraordinary internal reaction throughout Apollo when Honeysuckle acquired radio signal from Apollo 8 that confirmed the first orbit of the moon by humans. And then, most importantly, on December 24th, 1968, bedlam erupted in the Mocher when Honeysuckle again acquired radio signal as Borman, Lovell, and Anders came from behind the moon at precisely the right time to begin their journey home. Honeysuckle also supported collection of scientific information from the Apollo Lunar Scientific Experiment packages, one of which we deployed on Apollo 17. If someone asks what science did Honeysuckle serve, you can tell them that from the experiment and crew observational data you helped collect, we have vast, previously absent knowledge about the origin and evolution of the moon as a small planet. We also have the very first real understanding of the early history of the Earth, including the environment in which life began and how Earth's continents were formed. We also have new insights into the history of the sun, including why the sun warmed the Earth about 500 million years ago, when life in the oceans expanded in quantity and diversity. We now have executable knowledge of the lunar resources necessary to settle the moon, go on to Mars, and to provide clean fusion power on Earth. A heartfelt thanks to you and all our friends from Honeysuckle.
That's just a snippet of I can't remember how long the video went, but if you're interested in the Australian role in the Apollo program, NASA program more broadly, go to honeysucklecreek.net and you'll be there for hours looking at all the fantastic material. So that message was sent from Jack Schmidt to the trackers in Australia in their appreciation. So this is the final in the series. I've given up. And I did this for the association, so I hope you enjoyed it. And commemorating the 50th anniversary of mankind's greatest adventure. Thanks. Okay, so over on the bar there, some display material from John's AUSROC II thing. So that's it for tonight and this year. So we'll see you back on the 4th Monday of January with a whole lot of new information and a bit of fun. And thanks for your support for the members. We particularly appreciate you supporting the association. If you're not a member, consider joining. If your membership's lapsed, maybe come along and rejoin. But other than that, we do this for the love of it. No one's paid here, but we just enjoy sharing the fun. Thanks. Good night.